So that's the only thing that's special about a trapezoid. It has one pair of parallel sides, only one pair. The one below it, the isosceles trapezoid, we'll talk about that in another lesson, so we're going to leave that blank for today. So let's go over to the middle there. Parallelogram. Parallelogram's a nice word. A parallelogram is a quadrilateral. It's on the quadrilateral connected to the quadrilateral. But parallelograms have quite a few special things about them. Parallelograms have two pairs of parallel sides. So on your picture, you might want to, this is kind of the generic picture of a parallelogram. You might want to mark the opposite sides parallel. So those sides are parallel, and those two are parallel. Well, there are a couple of other things that are special about parallelograms. The opposite sides. Are congruent. So those two are congruent, and those two are congruent. Might want to mark that on there. And just a reminder, this might look familiar. This was on the back of our parallel line graphic organizer. So we have a class set of these completed that you'll be able to use on quizzes and tests. So our opposite sides are congruent. Still a couple more things. Opposite angles are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. Consecutive angles. Consecutive means two in a row. Consecutive angles are supplementary. And one other thing, the diagonals bisect each other. So let's remember, what does bisect mean? Cut in half. The diagonals cut each other in half. And what's a diagonal? You draw a little parallelogram. Diagonal goes corner to corner across the middle. So this would be a diagonal. So the diagonals cut each other in half. So all of those things are special or true about parallelograms. All right, we good there? Questions? Okay, let's go over to the left and talk about rhombus. Rhombuses are quadrilaterals. It's connected to quadrilaterals through the parallelogram. And rhombuses are parallelograms. So everything that's true about parallelograms is also true about rhombuses. So all those things that we put in the box or that you wrote about parallelograms, also true about a rhombus. In addition, a rhombus has 4 congruent sides. So our rhombus on our graphic organizer looks something like that. So we have 4 sides that are all the same. The diagonals of a rhombus are perpendicular. So the diagonals meet at a 90-degree angle. And the diagonals bisect the angles. So if we were to draw the diagonals in, we would cut each of these angles. The diagonals would cut each of those angles in half. So rhombus has all the properties of a parallelogram. In addition, the diagonals are perpendicular, the diagonals bisect the angles, and the 4 sides are congruent. You know how geometry students get to school? On the rhombus. All right. Rectangle. Let's go over to the rectangle. Rectangles. Rectangles are quadrilaterals and parallelograms. So all the properties of parallelograms are true about rectangles. And they have 4 right angles. And for rectangles, the diagonals are congruent. So if you wanted to add to your picture of your rectangles, you would put in your four right angles there. The diagonals of a rectangle being congruent is kind of an important thing. We'll talk about that in another section. So all the properties of a parallelogram are true for rectangles. Opposite sides are congruent, opposite sides are parallel. All those things are true. In addition, these things are true. 4 right angles, congruent diagonals. The kite that's over on the right-hand side, we'll talk about kites later also, so we'll leave that one blank. So let's go down to squares. So from the way they're situated on your graphic organizer, squares are connected to the parallelograms, to the rectangles and rhombuses. So a square is a parallelogram. Square is also a rectangle. And a square is also a rhombus. So all those properties of parallelograms, rectangles, and rhombuses are true for squares. The way we usually think of squares is 4 congruent sides, 4 right angles. So if you wanted to draw that on your square on your graphic organizer, 4 congruent sides, 4 right angles. The fact that the square is a rectangle and a rhombus and a parallelogram, I'm going to write out some, we could figure it out from those other things, but I want to make sure we have the detail. The diagonals. Bisect each other. They're congruent and perpendicular. All right, questions about our information on a graphic organizer? So what we're going to do moving forward, we often will be given problems that have to do with that they have some kind of special quadrilateral in them. We'll need to figure out some other pieces of information about diagonals, about sides, about angles. And then we might need to prove something about use it to solve a problem about triangles. So a diagonal divides this thing into triangles. We might need to figure something out about those triangles. We might need to find something out about parallel segments, because these special quadrilaterals have parallel segments. So what we're going to do is take this information and use it in addition to and build on the information that we talked about first semester. So really what we're doing is we keep building on the information we have, so we keep using it. So stuff about congruent triangles, side angle side, all that kind of thing will come in. Stuff about parallel lines with alternate interior angles, those kinds of things. We'll keep using that stuff in addition to this information that we have about quadrilaterals. All right, so that's all we're going to put on our graphic organizer for today. So I want to talk about one theorem, and then we'll do a few examples. This theorem doesn't have any special name, just a theorem. If 3 or more parallel lines cut congruent segments on one transversal, they cut congruent segments on any transversal. So what we're saying here is if we have 3 parallel lines, so there are 3 parallel lines, and there are 2 transversals, and I'm saying that these lines are parallel. I know they don't quite look like it. And we know that these 2 segments are congruent. So I'm going to call this ACE and BDF. So what we're saying is if line AB is parallel to line CD, and that is parallel to line EF, all 3 of those lines are parallel, and segment AC is congruent to segment CE. Then segment BD is congruent to segment DF. And if we have more parallel lines, all those segments on one side would be congruent, and all the segments on the other side would be congruent. All right, this theorem doesn't come up as much as the information about the special quadrilaterals, but it does come up sometimes. All right, so let's look at a few examples using some of this information. All right, and this is quadrilateral RSTU. And we're going to say this is a parallelogram. The symbol for a parallelogram is just a little parallelogram. So the way you'll see it in your book, it will be written like this, and then it would say RSTU. That means parallelogram RSTU. We want to find the measure of angle R. So we look at this, we say, oh, okay, we have a parallelogram. What do we know about the angles in a parallelogram? We have two sets of parallel lines. That's the information that we know about the sides. So if we could go about it that way. If these two are parallel, what do we know about these two angles? Same side interior, so they are same side interior angles. Or we can think of them as consecutive angles in a parallelogram. They are supplementary. You can look at your graphic organizer and see that. So we know that they're supplementary. So we measure of angle R is 180 minus 71, which is 109. And one nice thing about parallelograms, a lot like parallel lines, if we know one angle, we can figure out all of them. Because this one's 109, the opposite angles have to be congruent, so this one has to be 71. These two are congruent, so this one also has to be 109. We can figure out all the angles there just by knowing one. All right, questions there? Another thing that we might be asked to do is what we call classifying these quadrilaterals. So I'm going to say this is parallelogram FGHJ. We want to name it in as many ways as possible. So the way that your book will ask you to do it is they'll say classify. Classify this quadrilateral. I need to put some more information on here. Those two sides are congruent, and that's a 90-degree angle. All right, so we know this is a parallelogram. Let's start with the sides. What do we know about the sides of a parallelogram? Opposite sides are parallel. So does that help us? Does that help us name it any differently? We have two pairs of parallel sides. Does that give us any more information about another kind of name we could give it? That piece, we know it's a parallelogram, so we're good there. How about the lengths? Opposite sides are congruent. So we know since it's a parallelogram, that has one tick mark, and that has one tick mark. All right, now we have four parallel sides, or sorry, four congruent sides. What does that make it? Well, we have to know that all the angles are 90 degrees before we know it's a square. But let's, if all we know is that four sides are congruent, what do we know? It's a rhombus. So the fact that the sides are congruent tells us it's a rhombus. Now let's talk about the angles. What do we know about the opposite angles? They're congruent, so that has to be a 90-degree angle. What about consecutive angles? Supplementary, so what does this angle have to be? 90, and then what does that make that one? 90. So now that we have four congruent sides and four 90-degree angles, now we can say it's a square. Well, it also has four right angles. It's a parallelogram with four right angles, so what does that make it? A rectangle. And then the most general thing, just because it has four sides, it's a quadrilateral. So that would be all the different ways that we could classify that parallelogram. If the question asks you to give the most specific name, what would be the most specific name of that? Yes. Square. Square would be the most specific, because that tells you all this other stuff also. All right, we good there? Okay, let's look at a rhombus this time. So on these problems, it's very important on the problems in this chapter, don't go by what the picture looks like, go by the information that they give you. So I'm going to say this is a rhombus. I'm going to draw in a diagonal. And we're going to say this is 100 degrees. Call this angle 1, angle 2, and angle 3. And we want to find the numbered angles. Well, the first thing we should do is think, well, a rhombus is a parallelogram. So that gives us some information about the angles. So let's do the easy one first. What's the easiest angle to figure out? Angle 1 is easy to figure out. So what do we know angle 1 has to be? 100 degrees, because its opposite angles are congruent. Well, if this angle is these angles are 100 degrees, what does this whole big angle all together have to be? What is it? Has to be 80, right? Together they're 180, so these two together have to be 80. Because 100 plus 80 is 180. What do we know about the diagonals of a rhombus? What do they do to that angle? Bisects it. So what does each one of those have to be? 40. 2 comma 3 is 40. And then we can figure out all the rest of those angles. These are all 40. All right, questions? Last example. This one is a rectangle. And I'm going to draw in some diagonals. problem tells us that Pn is 7x minus 8. And MO is 4x plus 10. And we want to find the length of Pn. Well, let me use a highlighter for this so we get this information. Here's Pn. And here is MO. What parts of the rectangle are those? Diagonals. What do we know about the diagonals of a rectangle? They're congruent. So if they're congruent, what do we do with these two things? They equal each other. That equals 4x plus 10. And now we can figure out what x is. Subtract 4x. So 3x minus 8 equals 10. Add 8. 3x equals 18. Divide by 3. 18 divided by 3 is 6. X equals 6. Are we done? No, it says find the length. So we need to take x equals 6 and plug it in there. So Pn is 7 times 6 minus 8. 7 times 6, 42, minus 8, 34. So the diagonals are 34 units long. All right, questions? Okay. Homework. 2 different pages. One of the pages is just parallelograms. The other one is squares, rectangles, and rhombuses. I think that's how it works. All right, there's that. We turned in our homework in class yesterday.